Okay, now we're going to talk about two-step problems. Two-step problems are a challenge, but only if you don't think first. So, many of the challenges that many of you are encountering in class is that because you are not trying on your own, you are thinking that you can just plug numbers in and get the answer, and you really have to think through each problem. So this is one of those ones where you have to think through. So first, as always, read the problem. How many molecules are in 3.723.3 grams of C5H12? I did use a different substance this time. First, this is our known. And secondly, this is our unknown. Let's take a look at our mole map. How many molecules? That's our unknown. That is representative particles. Are this many grams? That is our known. Now, you guys can get all over the city to do whatever you want. So I know that you can do this problem right here. All you have to do is think. So you have to get from here to here. You have to get to Target, to Tenleytown, to that Wilson game. That means you're going to need to make a transfer. You're going to need to take the green line to Gallery Place. There's a couple other options, but I'm simplifying. Make a switch, get onto the red line, get to Tenleytown. Same type of setup. So you're going to start with Mass. You're going to take the A route to get to moles. Remember, moles is like our Gallery Place. Then you're going to switch lines. You'll take your B to get your representative particles. You're going to need 2 conversion factors because you need 2 trains. You cannot do this all in one step. Rephrase. You cannot do this with just one conversion factor, and I do not want you to do this into 2 separate steps. I need you to try to do this all in one setup to prepare us for what's coming next. So let's talk about what we need to do to set this up. First, we're always going to start with writing our knowns. And we always put our knowns in our groovy little yellow color. Then our unknown is the number of molecules. And just to remind ourselves, we're going to make that number pink. Okay? Now we need to think. We are starting with grams. So we're going to start with mass. We're going to need to get to moles, because moles is always our change of train spot. And then we're going to need to get to representative particles. This, from mass to moles, that's our A. And that is going to be green for us. And then representative particles is B. That is going to be orange for us. Remember that I write very large, so it's going to take me the full sheet of paper. If you are a writer like me, you may want to do this on a separate sheet of paper and put it in your notebook. If you write smaller, you still may want to do that just to know how much paper it's going to take before you get into it. So we can see that the first conversion factor we're going to need is going to be conversion factor A. Conversion factor A always has that same format. Blank grams of X is equal to 1 mole of X. By the way, if you are a visual person and color actually helps you, there is nothing wrong with taking the time to actually color in these boxes here to represent the same colors that they were on the chart. That actually may help you to wrap your brain around it a little bit better. So this was our red box, and then this was our purple box. And then we're ending in our blue box. If you find that that doesn't matter for you, then that's not something you have to do. But for some people, that makes a huge difference in your understanding. All right, so how do we find that? We should remember that we have to add up all those masses off the periodic table. So we have 5 carbons times 12.01 equals. Some of you are like, how does Miss Maddox know that? Because I've done chemistry for way too long. But if you look at the back of your periodic table, that's that 12.1 is coming from. So that gives me 60.05. And then next, I'm going to do the same for my hydrogen number. So I have 12 H's times 1.008. Now, I'm not that good, so I'm going to use a calculator for that one. I'm going to add those two numbers together. So I know that my A conversion factor is going to be 726. Sorry about the phone. Why I'm getting emails at 2 o'clock in the morning, I don't know. Let's not even talk about why I'm up at 2 o'clock in the morning. It's a whole nother conversation. Equals 1 mole of C5H12. And I'm just going to put this in green so when the time comes, I know what I'm looking for. Now, our B is the same exact B that it is for every problem. So if we go back, so looking at our mole map, our B was Avogadro's number, which is that 6.0 number right there. So 6.02 times 10 to the 23rd molecules. Don't abbreviate molecules. It looks like moles and it causes chaos. H12 is equal to 1 mole of C5H12. I did abbreviate the step of changing all of the X's and the word representative particle over this time, because at this point you guys should be pretty good with that after you've done all of your homework and your classwork. And we are going to label this one as our B. And then we're going to set up our conversion factors there. So where'd my little card go? There it is. I know I'm going to need most of this space this time because I have 2 conversion factors plus my known. And going back to what we talked about before, we are always going to use the conversion factors in the exact same order that we needed them. So we started with our known of mass, then we got on that green train, if you will. And then we used our orange train. Our known 372.3 grams C5H12. At the bottom of the next step, I need grams of A. This top first part of the equal sign has grams. That's the part that needs to go at the bottom. Whatever unit is here goes at the bottom of the next step. So 726.3648 grams C5H12. The other side of the equal sign goes at the top. Then the bottom of the next step. So we've handled grams. We now need to deal with this moles of C5H12. If I look at this quote carefully, C5H12, moles C5H12 is this part. That part needs to go at the bottom of the next step. It's always diagonal. And then this needs to go at the top. Okay. So my math is going to look like 372.3 times 6.02 times 10 to the 23rd divided by 7.26. I said 7.26. It's 726.3648. That's what my math is going to look like. Again, it's taking me so long because I'm not used to this calculator. And I have to do the calculation one more time because I accidentally pushed clear. How do I know when I've gotten the right answer? I know I've gotten the right answer because this is a really big number. being divided by a smaller number by comparison. So I should wind up with a really big number as my final answer. And if I don't, then I probably have done something wrong. It's already in scientific notation. Sig figs, we need 3. That has 3. That had 4, but this is 3. We always pick the least accurate number. So our final answer is going to be 3.09 times 10 to the 23rd molecules of C5H12. And circle it. And this is one of the things I mentioned earlier. You always want to go back to your top. Question was molecules. Did I answer that question? Yes, because that says molecules. Then I know I've done it right. Or it's a pretty good chance. Alright, we're going to do last problem, last 2-step problem, and then we're done.